This is section 7.2, triangle congruence theorems. Okay, so in the last section we were talking about triangles, and we were drawing them using our tools, and then we were trying to figure out if every single triangle we drew with those conditions ended up looking the same. Okay, so we had side, 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 which is SSS in this case, where we had three sides the same. We drew that out using the circles, and then we figured out that that was sufficient conditions. So our ones that end up being sufficient conditions actually have theorems that go with them. So the first one there, SSS, congruence theorem, is basically just side, side, side. So it says if in two triangles, three sides of one are congruent to three sides of the other, then the triangles are congruent to each other. So it's basically saying if you've got two triangles and all three sides match up, so like say maybe you had a triangle that was like, I don't know, 3, 4, 5, and then you had another triangle that was also 3, 4, and 5, then no matter what, those two triangles would end up being congruent to each other. Okay, so if you know all three sides are the same, then your triangles are congruent. Another congruence theorem we have is side angle side. So that one says if in two triangles, two sides and an included angles we talked about last section, where it's basically in between the two sides that they give us. So this would be the included angle here. Of one are congruent to two sides and the included angle of the other, then the triangles are congruent. So this one, when we go around in the order, you go side, angle, side. Okay, so side, angle, side would produce congruent triangles. Next one there we have ASA, so that would be angle, side, angle. So in your picture here, angle, side, angle. So that one, same situation. So if in two triangles, two angles, and an included side, so this one, your side is included. So that basically just means your side here is in between your two angles that are congruent to each other. Or not congruent to each other, but two angles that we know. And the included side of the other, then the two triangles are congruent. So basically, if you know an angle measure here, say it's like 20, this side is 5 centimeters, and this angle is 30, and you've got another triangle that's 20, 5 centimeters, and 30, then those two triangles have to be congruent with each other. Okay, so those are three of our ones that are going to be sufficient conditions, and every time you have those set of information, it'll always end up being congruent. Okay, so we're going to look at one on the example sheet here. So basically for the first example, they want us to prove that these two triangles here, so MNO and PQR, are congruent to each other. Okay, so I set it up on the back here. So the first thing they've got is that 40 plus 55 plus angle O are equal to 180, so that means the measure of angle O is 85. So if you look here at this triangle MNO, we've got 40, 55, and O, and those have got to add that 180 by our triangle sum theorem. Okay, so in that triangle sum theorem, so that's our explanation here, so triangle sum theorem. So what that theorem says is if you've got the three angles of a triangle, those always add together to be 180. Same situation for the second one here. We've got the other triangle, so we got 40, 55, and then this time angle R, and those again are going to add up to be 180 because it's a triangle, so that's also by triangle sum theorem. And then the last one here, what we're doing is we're looking at what they give us. So we've got angle O is congruent to angle R. So that angle and that angle match up because those were both 85, right? And then we've got that ON, which would be this side here, and RQ, that side there, are congruent because those are both 8 centimeters, which they told us originally. And then we also know that angle N and angle Q match up to be congruent because those are both 55. And then what we want to do is we want to pair a congruence theorem, one of the ones we just wrote down, with our situation here. So this would be an angle, side, angle congruence theorem. So angle, side, angle, ASA, congruence theorem. Okay, because you've got that angle, and then a side, and then an angle, your original angle, that side, and then an angle matching up. So that would be by the angle, side, angle congruence theorem that both of those triangles would match up to be congruent. Okay, what do we got next? So we got another congruence theorem. So this one is angle, angle, side. So this one you've got an angle, and then you've got another angle. So we kind of skipped this side here and went angle back to back with an angle, and then a side after that angle. So this one says if in two triangles, two angles and a non-included side, so a side that's not in between the two angles they give you, of one are congruent respectively to two angles and the corresponding non-included side of the other, then those triangles are congruent. So if we've got an angle, skip that side there, go to another angle, and then we've got a side that's not in between those angles, this would also produce congruent triangles. So this one would be sufficient conditions. Now this last one here, third angle theorem, is a little bit different. So it's basically thinking of a situation that's like angle, 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 because it's got if two triangles have two pairs of angles congruent, then their third pair of angles is congruent. So this one is not saying that angle, angle, angle produces congruent triangles, because it does not. What it's saying is if you know two of these angles are the same, so maybe this one's like 20 and 30, and then this one's 20 and 30, then whatever you're missing one is the same, because they, would add to 180. But we can't say that these two triangles would be congruent, because we showed in the last section that they were not congruent to each other. Okay, so if you've got angle, 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 that is actually not sufficient conditions. So angle, angle, angle is not one of these. Okay. And then we've got one more example here. So back on our example sheet, we've got another proof. So it says prove that the diagonal of the parallelogram, so we got a parallelogram here, divides it into two congruent triangles. Okay, so here we've got PAR, that top triangle there, is congruent to RLP. Okay, so first thing there, it says it's a parallelogram. And then it says, because it's a parallelogram, we've got AR, that side, is parallel to segment LP, and the AP is parallel to LR. Okay, and we know that by definition of, well, we're talking about parallelograms, so definition of parallelogram. Because in that definition, it just says you've got two pairs of parallel sides. And then the next thing we're looking at here is angle APR. So angle APR, that one, and angle LRP, that one, are congruent to each other. Well, if I think about kind of extending these lines out here, how would I have to extend? I would have to extend those, and that, and that. If you look at those angles, those are following that Z-type shape. So when we follow that Z-type shape in between our parallels, those would be alternate interior angles. So this blank here is alternate interior angles theorem. And then that also works for the other one they list there is ARP, so ARP, that one, and LPR, that one. Those would also follow that Z shape, so that also fits the alternate interior angles theorem. So now they're saying, okay, well, we know this angle matches this one matches this one. Now they're saying in those triangles, segment PR is congruent to segment RP. Well, if you look there, P to R and R to P, those are basically the same exact line, right? So they're saying those match up with each other. And we know that one by reflexive property. So reflexive property of congruence, because basically anytime you've got like the same line or the same angle that match up with each other, that's just always reflexive. So because that side is the same for both of those triangles. We know it's congruent by reflexive property. And then now we've got to pair the three-letter congruence theorem that matches this situation. So what I would think here is I'd go, okay, well, I've got an angle, I've got a side, and I've got an angle. Same situation on this bottom triangle, angle, side, angle. So this has got to be the ASA theorem. So ASA congruence theorem. So you're basically just looking at the order of the information that they give you and matching the congruence theorem that matches with the order that they give. Okay, so that is it for notes. So you've got page 390, 2 to 8 even, 10 to 14 all, and then also 16.